Okay, here we go. Let me zoom in so y'all can see. This is what we did yesterday together. We did number 1. We all did that together, yes? Number 2 is what you're supposed to work on last night. G of x. So just to make sure we're all clear about kind of how this thing is supposed to go, here's your input. Output is just whatever the y value was. So for -3, when you look at the picture, what's the answer? 2. You're just looking for the colored in dot. At -2, what was the answer? 0. Okay, give me the rest going down. -1, -1, -1, 0, 2. Everybody got that? And I'm just going to trust that you are correct if I don't have it in front of me. All right, for the left-hand limits, what's it approaching from the left? If we're approaching -3 from the left, we're approaching 2. If we're approaching -2 from the left, we're approaching 2. You've got 3 options here, but we're coming from the left, so it has to be 2. Does everybody see that? All right, if we are approaching -1 from the left, is it 1 or -1? It's +1. Good. Okay, give me the rest going down. -1, -1, 1, 2. Everybody agrees on that? We're okay? All right, right-handed limits coming from the right toward -3. If I'm coming from the right toward -3, I've only got one option here. It's 2. If I'm headed toward -2 from the right, I still have 3 options. Which one is it? It's 1 because you're coming from the right. So it's 1. All right, Yaron, give me the rest going down.
-1, -1, 1, 2, and 2.
Do you guys agree with them?
Yeah.
Nice job. Now, do you have to look at the picture for the next column? You don't have to. If we're coming from the right and the left and they're both approaching 2, the limit is 2. If we're coming from the right and the left and they're approaching different numbers, it's does not exist. So we have 2 does not exist, does not exist, -1 does not exist, does not exist, and 2. Questions? All right, continuous. You can't always tell from these 3 numbers here. You can't always tell. Sometimes you'll have 3 numbers here that match, but it's still not continuous. That happened, I believe, on this little guy here. There was a limit at 1, but it was discontinuous because it was right at +1. So you had to be really careful on that one right there. For this one right here, I believe we've got continuous is yes, no, no, yes, no, no, and yes. Is that what you guys have? Terrific. These 2 charts you're going to use for the rest of the assignment. Yes, sir.
So is it if those 3 match the output, then it's continuous?
If all 4 columns match. Yep, if all 4 columns match, then you're good. Good question. We're going to use these 2 charts to help us with the rest. And these will work best, guys, if you handle the chart first and graph last. If you start from the graphing piece, you might make yourself a little bit crazy. So let's look at number 3. Now we're going to chart for h of x where we're adding the 2 functions together. Now because we're talking about limits here, and because this is kind of an activity that we can kind of put some notes on, everybody write this down. The limit as x approaches a from either the right or the left for h of x, if that's what we're looking for, and you don't want to take the time to add the 2 functions together, which you can't because you weren't given equations anyway, then the rule that you wrote down last week in your notes says you can take the limit as we approach a from either side for f of x and add it to the limit as we approach a from either side for g of x. So you can take the 2 limits and add them together. And it's the same answer as it would have been had we added the 2 functions and then found the limit. So for this first one right here, it doesn't say anything about a limit. They just want the output of the 2 functions put together. So on the front, and I have, oh man, I gotta get the key. Anyway, we're gonna have to do some flipping back and forth, I think. I know, gross. For -3, if you put in -3, for f of x, you get -1. For g of x, you get 2. What's -1 plus 2? 1, so put that blank. You just have to add the outputs together. So for the next ones, and I'll just leave this up here so you guys don't have to do the flipping. If you put in -2, we have 0 and 0. What's 0 plus 0? 0. The next column down, or row down. 1 plus -1? 0. 0 plus -1? -1. 1 plus -1? 0. And 0 plus 0? Last one, 1 plus 2. Okay, somebody help me out and tell me what we just did. 1, 0, 0, -1, 0, 0, 3. Thank you. Left-handed limit is going to work the same way because of this rule. If we take the left-handed limit for f and add it to the left-handed limit of g, we'll get what we're looking for, the left-handed limit of h. So, for -3, the left-handed limit of f of x is -1. For g of x, it's 2. What's -1 plus 2? Write it down. 0 plus 2 is 1 plus 1 is 2. 0 plus -1 is -1. -1 plus -1 is -2. 0 plus 1 is 1. 1 plus 2 is 3. All right, Logan, tell me what you just wrote down.
1, 2, 2, -1, -2, 1.
Okay, right-handed limits, exact same rules. Here we go. Right-handed limit for f of x, right-handed limit for g of x. We add them together. -1 and 2 is 1. Write it down. 0 and 1 is 1. -1 plus -1 is -2. 0 plus -1 is -1. -1 plus 1 is 0. 0 plus 2 is 2. 1 plus 2 is 3. All right, next Smith, what we got?
1, 1, -2, -1, 0, 2, 3.
Thank you. Now, do we need to consult the other charts to get this next column? Look at what it's asking. It says, what is the limit from both sides at the same time? Well, for -3, as we come in from the right and the left, they're both approaching 1. So what's the limit? 1. For -2, they're both approaching different numbers. So it doesn't exist. You finish that column yourself. Yours should match mine. Let's deal with the continuity last. Now we're going to do the graph. First thing you can do is, we've got x's, we've got y's. Let's go put dots for the first two columns here. So -3, 1 is a point on the graph. Closed in dot. -2, 0, closed in dot. -1, 0. 0, -1. 1, 0. 2, 0. And 3, 3. So yours should look like mine. So far. Questions so far? All right, now we've got this limit business. Remember, a limit is what we are approaching. So those are all going to be open circles because we're approaching that value without actually touching it. So we've got -3, 1. I need to put an open dot there, but I already have a closed dot, so leave it alone. It's fine. Next one, -2, 2. Go to -2, +2, put an open circle. Next one, -1, -2, open dot. 0, -1, we've already got a dot there, so we don't need to touch it. 1, -2, open dot. 2, 1, open dot. And 3, 3, we already have a dot. So we're good. Now we need to do the right-handed limits as well. -3, 1, we've already got a plot pointed there, or a point plotted there. -2, 1, we've already got an open dot. -1, -2, we're going to have an open dot there. Oh, -2, -1, I'm sorry. Thank you. -2, +1, sorry. -2. -1, -2? Do you guys all have -2 here? That one
Yeah.
is what? That's what I wrote.
No,
You gotta get to roll and graph it.
My bad. Thank you. Good catch. Is that correct now?
Yep.
Okay, sorry. Thank you. 0, -1. We already have a point. 1, 0. We already have a point. 2, 2. Open circle. And 3, 3. We already have a point. So we've got a mess of chickenpox going on up there, basically. Here's how you're going to connect your lines. It takes a little bit of logic, and you just have to read the limits. So if we're looking, let's just start at the beginning here. If we're approaching -3 from the left, we're approaching 1. So that one's easy. We'll just leave it at that. For -2, from the left, we're approaching 2. From the left, we're approaching 2. So that tells me 1, 2. It's going to be connected to this dot. Now you got to put your thinking caps on. For -1, as we approach from the left, we're approaching 2. The problem is I don't know if it's coming from which dot. There's 3 dots it could come from. I know out of these 3, I'm approaching 2, but I don't know which of these 3 it's coming from. So let's back up. As we approach -2 from the right, it's at 1. That's this guy. So we connect them. You kind of have to use some logic to kind of put them together. Let me say it again. As we're approaching -1 from the left, I'm going to 2. That's this guy right here. So before I connect any dots, I have to know which one of these 3 to connect it to, if any. So I say, okay, -2 from the right, so coming this way, is headed toward 1. So it meant the middle dot. So let's keep going. If we're approaching -1 from the right, we're headed toward -2. So this is the one we're coming from. If we head toward 0 from the left, we're headed toward -1. Headed toward 0 from the right, we're at -1, so I start from this dot. Then I'm headed to my left-handed limit, and I'm approaching -2. So out of these 2 dots, I'm approaching the bottom one. You guys kind of see how this logic is working? You finish the graph. Once you get your graph to match mine and you feel pretty good about that, you can fill out the continuous piece. Everybody okay? Using this same rule up here that we did for addition, it works for subtraction as well. So you're going to do the same thing on number 4. On number 5, multiplication has the same type of rule. So you can write down that the limit as x approaches a from either side for h of x, remember that's a question, is the same thing as finding the limit for f of x and multiplying it by the limit for g of x. Same kind of process, but you're multiplying this time instead of adding or subtracting. For number 6, the limit, bless you, as x approaches a from either side for h of x, because we're taking 2 times f of x rather than doubling the function itself, we're going to double the limit as x approaches a from either side for f of x. Questions? All right, unstaple your papers because you need the front page. You want to look at your 2 graphs or your 2 charts. Flip it over to number 7. The limit as x approaches a from either direction for h of x. Whoops, that's an h, my bad, sorry. And we're looking for f of g of x. Last week in your notes you wrote down that to get this you can also take f of the limit as x approaches a from either side for g of x. So rather than finding f of g of x, which is kind of a nightmare in and of itself, and then finding the limit, just use what we know about the limit of g of x and plug it into the function f. We're going to start this one together. So everybody have that much written down? Okay. Here's what that looks like. Input, output. We don't have to mess with limits yet. We just need f of g of x, which means you're taking g of x, you're plugging it into f of x. So if I put in -3 into g of x, my output is 2. Take the 2, put it into f of x, and I get what? 0, so write down 0. If I take -2 and plug it into g of x, the output is 0. Take 0 and plug it into f of x, the output is 0, so write down 0. You guys kind of see how this is working? -1 into g of x, put it into f of x, you should get 1. You finish that chart yourself. Or that column yourself, I'm sorry, just that column. By the way, these graphs, when you graph them, if you get a bunch of straight lines, you're supposed to. They look kind of weird. Of course, they all look weird. Did you guys get what I got?
Yeah.
Okay. The limits. Remember, here's our rule. We take the left-handed limit for g of x and plug it into f. So, -3. -3 into g of x. I'm concerned with the left-handed limit, so my output is 2. Put in 2 into f of x. Don't look at the left-handed limit. You're just concerned with the output. It's 0. Because notice what the rule says. It doesn't say the limit of f of x. It says the limit of g of x and plug it into the regular old function of f. So let's do the next one. -2. Put in -2 into g of x. The left-handed limit output is 2. Put 2 into f of x. The output is 0. I'll do one more out loud. -1. Put -1 into g of x. The left-handed limit output is 1. Put 1 into f of x. The output is +1. You finish it. Your column should match mine when you're finished. The right-handed limits work the same way. Go ahead and do that column as well. You what, Ocean? You're getting a bunch wrong. Is your chart correct? So I think, Ocean, if I had to guess what's going wrong with you, here's what I'd probably say. If you put in -3, and we're looking for the left-handed limit, it's 2 for g of x. Take the 2 and you plug it in, and you put just regular output as the answer. You were probably using left-handed limit. Yeah, you got to look at your rule that we wrote down up here.
Okay, I got a question.
Yes, sir.
It was like, my question did it be like x goes towards a.
It wouldn't have been written like this. It'd be a totally different question. Good question, though. This next column, do you need charts at all? No, look at the 2 columns you just wrote. Go for it. Once you have that, I'm going to let you guys do the graph and the continuity. When you finish the graph and the continuity and you check with your neighbor and you guys kind of agree on it, go back to number 4. You guys do number 4 together and then just finish up the page. Freeze that for y'all.